Signed number representation. Syntax is given by, means we are going to give the reserved bit for the sign and we will have the binary equivalent in ones complement. So if you take example of -25, first we are taking the magnitude which is 25. So its 25 binary equivalent is given by 11001. So after applying ones complement, what are we doing in ones complement? We are interchanging the bits ones from 0 and zeros to 1. So with this we got the ones complement. Now its equivalent is given by sign bit. One bit we are providing as a sign bit. Then the ones complement equivalent is 0 0 1 1 1 0. So this is a -25 ones complement representation. Okay, -25 ones complement representation. Now let us move to the twos complement representation of the same number. So if you take the same number, so the syntax for this one is twos complement. The syntax is provided like this. Again you will have a fixed reserved bit for the sign. Then you have the twos complement binary equivalent. So you understand previously, in the previous case what we have done, we have taken the LSB and we added 1. So with that we got the twos complement over here. But if you go, okay, we got that as ones complement, so what we need to do? 1 0 0 1 1 0. So we are only concentrating on the magnitude value. So for this, again take your LSB, add 1. Then what you get? 1 1 1 0 0. So this is a magnitude equivalent of twos complement of 25. So what is -25 in twos complement form? Twos complement is given by the reserved bit is fixed. We are not changing that, so it is equals to 1. Then your number is 0 0 1 1 of -25. So one observation you can do is, even though you apply ones complement, twos complement or whatever it is, always the sign bit will not change. Sign bit is not going to change. One is as it is, because after doing ones complement, what are you doing? You are shifting. So this is also fixed. So there is a trick for writing ones complement. What is that? Not ones actually, twos complement. Instead of adding and doing all the things, we have a trick for that. What is the trick? I'll tell you. So I'll take 1 0 1 0. Okay. If you are special, it is a signed number. Okay. So ones complement means directly to write a twos complement, what you will do is, we'll start counting from, this is right to left. If I assume this is a sign number, negative number, so when you are writing twos complement directly, start counting from here. So if you start counting from here, count till you get 1. So 0 1, then you stop. From there you reverse the bits. So this is 1 and this is 0. Because this is sign bit, I am not disturbing. If you want, you can check out. So take the same thing, because it's sign magnitude. This is 1 0 1 0. What is ones complement? 0 1 0 1. Then adding 1, so this is 1 0 1 1 0. Did you get the same answer? So no need of converting, adding and everything. Simply start from the right side. Right, this is from right side. Wherever you come across with 1, till that you stop. 1 వచ్చిన తర్వాత, then later you reverse the bits. So this is a simple trick when you are writing your big paper. Directly twos complement number is given for you. So please start from the back. LSB, start from the least significant bit. Till 1 you count. After 1 you start shifting the bits. Not shifting, complementing the bits. Okay. Make 0 to 1 and 1 to 0. Now with this, so now you understood how we are going to represent the ones complement signed number, twos complement signed number. Got the point? Ones complement signed number means bit, then the binary equivalent after performing ones complement on the magnitude. Then twos complement is nothing but sign bit reserved, we are not disturbing. Then the binary equivalent of the twos complement of the number what you are considering. So this is how we are going to represent the signed complement numbers. operation. How we are going to do addition using this complement